Welcome to this tutorial of LayerZero V2. For this tutorial, I'm just going to go through the hands-on implementation of LayerZero V2. I'm not going to go through the concepts of LayerZero V2, the architecture. I've prepared diagrams, but I'm not going to cover that today. Hopefully, I would be putting out a video on that sometime soon. I'll do it faster if more of you request it as well. So before we go to the official getting started that LayerZero has written, I'll be explaining the concepts that you need to be aware of for this implementation. So since LayerZero is a messaging protocol, of course it involves communication between different chains or different networks. In the getting started, the examples involve Ethereum, Sepolia, and Optimism Sepolia. Aside from deploying the contracts on the two separate chains, there are several actions that would need to be taken in order for the message to be sent. Before anything, the contracts at source and at destination, we need to call this set peer. This is an allow list function that helps to limit the messaging to only allowed contracts. Otherwise, as you can imagine, there will be a lot of spam in the contracts. So set peer has to be called both at the source and at the destination. And after that, the sender contract would need to call quote so that it would know how much gas needs to be sent, or native token that would need to be sent while calling the send message function. It's worth noting that you can overkill with the value, and it would just be refunded back to message.sender when it comes to sending the message. But of course, ideally, you want to supply the exact amount of gas token needed to send the message. There is an option as well to pay with the LayerZero token based on the contract, but there's no LayerZero token yet. That would maybe be launched sometime this year. But right now, it's only with the native token of the chain. Okay. So I've mentioned about set peer, and LZ send is the internal function that would need to be called in order to send the message. And as I mentioned, it's fine if you send a little bit too much, because that will be refunded in the same transaction. But if you send too little, then the message is not going to be sent. Peer address has to be 32 bytes. I will explain this as we go through it. But for now, let's get started. So here you can see the signature of the LZ send function, and also LZ receive that would need to be called on the destination contract. So we'll just use the examples that LayerZero has provided, the example contracts. Thankfully, they have deployed remix templates. Now, the thing that they don't mention here, but I would recommend heavily to you, is to use two different browsers, each with its own MetaMask, because it would make it a lot simpler, especially in this case where you would need to switch between networks. Same if you're testing things out on Chainlink. It's the same thing. It can get really confusing if you use one browser and you keep switching networks. So here I'm already on Ethereum Sepolia, and I've got another browser here. I'm using Opera that is on Optimism Sepolia. So open up these two links. They would open up to the source contract and the destination contract over here. So you don't need to make any modifications to the contract itself, but you can see that the destination contract has an LZ receive function, and the sender contract has this send function that inside it calls _LZ send. So the source contract, this function can be named whatever, it doesn't matter, but the destination contract, the name of the function has to be this, because otherwise LayerZero won't know which function to call. Okay, so prerequisites, you need to set up wallets, and they need to be funded, right? I've written a markdown to make it easy for you to find the links that you need. So in order to get Sepolia ETH, you can use this link, and this is the most guaranteed, I think, because a lot of the other links sometimes they don't process the transaction and you don't get the ETH. But this POW faucet, it basically makes you mine for the Ether, which is a sure way of getting Ether. So it might take some time, like a minute or two, but then you would get it. So paste in your address and it would start mining. So after 2 minutes, you can stop it and you have enough Sepolia Ether. For Optimism Sepolia Ether, it's a bit easier. So Optimism has this faucet that gives you Ether actually for multiple chains at once. You can just verify or link with your GitHub and you would get 0.05 ETH immediately for these chains. Okay, so now that you have your MetaMask set up and funded, let's proceed. You need to deploy the contracts. And if you take a look at the contract here, it expects 2 arguments, right? Endpoint and owner. So endpoint refers to the LayerZero endpoint that the contract would interact with when it's sending a message. And owner, this one has to be you. So you know, in a way, it doesn't really matter for this contract because there's nothing in this example that requires ownership, but it's just that this is an ownable contract, like the way that they've set it up, it's ownable. So you need to pass that in. So let's supply the information. The thing that I would point out here is that the documentation here is wrong. So I tried this out a week ago and I was stuck. Then I realized that the endpoint address is wrong, right? So if we go to Sepolia, you can see that the endpoint is supposed to be an address starting with OX6ED, but here it's listing another contract. And if we check this out, we go to Sepolia tests Etherscan, we'd see that this contract actually was last active 33 days ago. So I've written about this as well in a markdown, which I'll link in this video. It should be this one, based on the documentation as well, the list of endpoint addresses. So you can see that this one has been quite active. These are the receive transactions. Okay, so we need the correct endpoint address. So this is the source contract endpoint, and owner should be my own address. Okay, and you know, I know it's the same, but just to show you, Optimism Sepolia has the same endpoint address. So this is the browser that has the MetaMask connected to Optimism Sepolia endpoint, and for the owner, I have to pass in my own address. Okay, so let's, oops. Okay, it has to be the injected provider because we want to deploy it to the actual testnet. So this one as well, injected provider. Let's try to deploy it on the source chain first. Okay, that's pending. And for this one, so I might have mistakenly provided value. So now we call it, oops, confirm for both. Okay. Now that's confirmed. Okay. And so is the contract on the source chain. It's now deployed. So moving forward, Now you need to call set peer. The contracts are deployed, but they need to trust each other, right? Before the message sending can be done. So we would need two things: the address of the other contract and also the endpoint ID. So here, I've also made it easy for you guys. It's also here, but I find that the wording is quite confusing. It says to send to Ethereum Sepolia, to send to Optimism Sepolia. But then we're sending only to Optimism Sepolia from Ethereum Sepolia. I think they should, make this a bit clearer. So I just plainly list out the IDs. So, from Ethereum Sepolia, we would need to trust Optimism Sepolia. So we take this endpoint ID, call set peer. Okay, yeah, sorry, I guess owner is needed because set peer is a function that only the owner should be allowed to call. So I take it back, it's still important for this. Okay, so endpoint ID is there, and peer has to be the address of the contract, the other contract. So in this case, the Optimism Sepolia contract. So we call that. Okay, so as you can see here, incorrect data length. So one thing to note about set peer is that the address is expected to be 32 bytes, and an EVM address is 20 bytes long, right? So we need to convert the regular Ethereum or EVM address into 32 bytes. And in the markdown, I have included an explanation regarding this. So in order to convert from 20 to 32 bytes, we need to understand the relationship between a hex number and bytes. So 1 byte equals to 8 bits, and a hex number can have 16 possible values, and 16, in binary form, it would be 1111, and that's 4 binary digits or 4 bits, which is half a byte. So each character is half a byte. So in order to have 1 byte, you need 2 hex characters. So if we need to add 12 bytes, you times it by 2, right? So you need 24 hex characters, and since we're not altering the value, but we're just zero padding it, it's going to be 24 zeros. So here I've included 24 zeros for you for free. So when you call set peer, what you need to do is to insert those zeros to the beginning, right? After 0x, and then you call set peer, confirm. And now we'll go to the other side, and we need to call set peer as well, so that we can receive the message. So set peer, we need the endpoint ID of Ethereum Sepolia, which is the source chain. Okay, and peer should be the address of the source contract. And again, we would need to zero pad this. Cool. So the reason that the address has to be zero padded is that LayerZero wants to support non-EVM chains. Solana, so we know that Solana support is coming soon. And Solana's addresses are 32 bytes. So that's the explanation as to why it needs to be 32 bytes. They might support other chains as well. I'm not aware of which other chain has 32 byte addresses, but I know that Solana's addresses are 32 bytes. Okay, so we've called set peer, right? So now we're ready to send a message, but before that, we need to know how much gas is needed, how much of the native token is needed. So we need to call quote, and quote would expect a number of parameters: destination ID, message, options, and pay in LZ token. So as I've mentioned, the LZ token is not launched yet, so we're not going to pay with it. Destination ID, this one has to be the endpoint ID of Optimism Sepolia. Message can be anything that you want it to say. So you can say hello from Ethereum Sepolia. Okay. And options, we'll just use the value that the documentation tells us to use. In this options, we're specifying 200,000 Wei as the amount of gas to pass to the executor. That will be converted into the destination gas token, sorry. Okay. We're going to call it, and we'll get the value of how much Wei to send. Okay. So now we need to attach the value. Scrolling down, we're going to call send, right? So send destination ID has to be Optimism Sepolia. The message is going to be the same as what we wrote in quote. Options, this one has to be the same, else it will fail because we call quote. If we call quote on a different options value, then the gas calculation is wrong, right? Confirm gas/fee. Okay. So once it's sent, LayerZero's relayer will be processing the message. Actually, for V2, the terminology is executor. It's not relayer. Relayer was a term from V1. Okay. So now that the transaction has been confirmed, we take the transaction hash and we can go to LayerZero's scanner and paste in the transaction hash. It might take a minute or two. And while that's waiting, the way that we can check if the message was sent is by calling data. So right now, since the message has not been processed yet and has not been sent, the destination contract's data shows nothing. And now LayerZero scanner has picked up the message, and you can see that the status is in flight. So it's not yet reached its destination. So now it's delivered. So let's go back to Optimism Sepolia and call data again. And you can see that the message was successfully delivered exactly as we wrote it. So that's it. Hopefully that was useful. I hope LayerZero fixes that wrong endpoint address in the documentation. I can only imagine how many developers get stumped by this and they don't continue because the message is not picked up. So if you specify this endpoint address, it's never going to show up on the scanner. So as I mentioned earlier, I might make a video explaining the overall architecture of LayerZero V2. If you want to see that come soon, let me know in the comments. Hopefully that was useful. Happy building. Goodbye.